We're going to take the next few minutes looking at the most popular color modes in Photoshop and the role that bit depth plays in their ability to store information. So bit depth specifies how much information is available for each pixel in an image. The more bits of information per pixel, the more values are possible and the more accurate tonal representation can be achieved. So in this example, we see an image that only has a bit depth of 1. It can only display 2 possible values, black or white, and as a result, bitmap images are not very common when working with photographs. Now, if we increase the bit depth to 8, then our images can contain 256 possible tonal or color values. There are 3 common types of files that are all considered to be 8-bit, but have very important differences based on the values that they contain and the number of channels. The first would be a grayscale mode image. An 8-bit grayscale image can have 256 possible values, but it's limited to 1 channel. In most instances, 256 shades of gray represents an adequate number of tonal levels to display what would appear to be a continuous black and white, or I guess more accurately, a grayscale photograph. The second mode is index color. It's similar to the grayscale mode in that it can contain 256 possible values, but in this case, those values are colors, not shades of gray. Like grayscale mode, index color is limited to a single channel, and this helps keep the file size down, but in most instances, index color mode is unable to display a large enough spectrum of colors to render a continuous tone photograph. Now, in this video, it might look like this is a continuous tone photograph, but if you had an image that had a lot of different colors in it, you would start to see a dither pattern, or you just wouldn't see all of the colors being represented accurately. Index colored images are primarily used when the file size needs to be very small. For example, if you're creating an ad banner or another type of image to post online. Now, the third color mode is RGB. So similar to the grayscale and index color modes, an RGB image can have 256 possible values. But the difference is that an RGB image has 3 channels to store this information, a red, a green, and a blue channel, whereas the previous color modes were limited to 1 channel. So if you have 256 possible values for each channel, then you can have over 16 million possible color values. So you take the 8 bits times the 3 channels, and you end up with 24 bits of data for each pixels. So in most instances, an 8-bit RGB image can represent continuous color in a photograph. However, 8-bit images obviously don't represent all of the tonal levels or all of the colors in the world. There are certainly values that aren't represented, which can result in an inaccurate representation of a scene. In addition, the quality of an 8-bit image can decrease rapidly when making large changes to color and tonality in post-processing. So to help solve this problem, we can work with both 16-bit grayscale and 16-bit RGB images. So a 16-bit grayscale image can contain over 65,000 shades of gray, far more than the 256 values per channel possible in the 8-bit grayscale image. And 16-bit per pixel RGB images will have over 65,000 possible values for each channel. So literally trillions of colors to work with. But it's always good to remember that this far exceeds both our ability to perceive color as well as the number of reproducible colors. So why do we need 16-bit? Well, if we look at this original image and we look at the histogram, which is something we'll be talking about more in depth in later videos, we can see that it's nice and smooth. But if I'm working with an 8-bit file and I need to make a big change to, for example, lighten up the image, I get these gaps in my histogram, which are areas where there's no values. Whereas if I'm working with a 16-bit image and I make that same change, I don't see those gaps in the histogram. So I have a lot more latitude when I'm making edits in 16-bit. Now, I should also mention that Photoshop does support 32-bit images, and they're sometimes referred to as high dynamic range images, but they shouldn't be confused with the popular high dynamic range imaging or HDR imaging techniques that photographers are using today to basically blend multiple exposures of the same scene into a single raw file using software such as Camera Raw or Lightroom. Because those files, even though they're called HDR, they actually have a maximum bit depth of 16. So the HDR 32-bit images, those are used by industries such as film and gaming, and they're true 32-bit images, and they're created when they render like 3D objects or other computer-generated imagery for special effects. Now, 32-bit files can get very large very fast, and since not all of Photoshop's features are available in 32-bit, and because most output devices don't support 32-bit images, these 32-bit images are typically converted to 16-bit or 8-bit at some point in the workflow. Now, let's see where we can control our bit depth in Photoshop. First, when I use File and then New, on the right-hand side, I can choose between creating an 8-bit, 16-bit, or 32-bit image. I'm going to close out of this, and let's move to Bridge. If I click on this JPEG file, well, we'll notice in the metadata area that the bit depth for JPEG files is 8-bit. So if I open this image into Photoshop, it will open as an 8-bit image. If, on the other hand, I double-click on the flower.dng file, which is a RAW file, it's going to bring it up in Camera Raw. And at the bottom of the preview area, I've got a workflow hyperlink. If I click on that, we can see that I can choose what bit depth to open this image into in Photoshop. If you're working with Lightroom or Lightroom Classic, by default, they're set up when you choose to edit in Photoshop to open those files as 16-bit. So I'll open this image as a 16-bit image. Like I mentioned, it will be larger than the 8-bit image, but I'll have more editing flexibility. And if I ever needed to change the bit depth, I could choose Image and then Mode, and then convert from 16-bit to 8-bit. This is also where I'd convert from RGB to grayscale. And we mentioned the index color as well as the bitmap modes. Well, I'd actually need to convert to 8-bit, throwing away all of that information before I could return to the menu and then choose either index color or grayscale. And if I wanted to go to bitmap, I would need to go to grayscale first and then choose image mode in order to access bitmap. So for the most part, choosing the correct bit depth comes down to the size versus the flexibility and quality when you're editing your images. An 8-bit image will always be smaller than 16-bit. However, 16 and 32-bit images contain more information and can produce higher quality results when large manipulations are made to the files. I prefer to work in 16-bit whenever possible. The larger file seems like a fair trade-off for more colors and tonal information when making edits to my images. If you're using the exercise files for this course, you'll notice that many of them are in 8-bit, but that's just to save on file size.